This is the LinqToXML demo. This is going to be a short demo demonstrating how you can use your knowledge of XML and LinQ together to query and to create XML documents. In this particular program, we have our main function. Let me call your attention real quick to the pause method up here. Simply a place for me to do console read lines and write lines to pause the action in the program instead of having them in line. You can see the pause function called periodically throughout our main function. The first thing that's done within main is we make a call to make XML doc. Let me scroll down to that function so you can see what it does. As you can see here, it is a static method that returns an X document. The first thing we do is we create a new X document. We're going to call it doc, and we set it equal to new document. Now we are going to use the LinqToXML X document object to build all of its children as well. Because when you create a new X document, it allows you to pass in a parameter array of other X elements. In this case, we are passing 3 elements or 3 items to the X document constructor. We're passing it a new X declaration, which will give you the XML declaration at the top of most XML files. We're also going to pass it a new comment, an X comment object, and then we pass it a new X element, which will be the root node of this document. Now for XML, there can only be one root node. One thing to note here is the declaration and the comment do not count as the root node, as they are just metadata within the XML document. Then, as you see, we're doing the exact same trick with the X element constructor. We are telling it we're creating a node called students, and then we're passing it 3 elements as a param array. We're passing it 3 X elements with the tag name or the node name of student. And again, as we look at the individual X element student objects, we are passing it a series of objects as well. In this case, we're passing an attribute called ID with 1, 2, 3, 4, 5, 6 as the value, and then passing it 3 elements, first name, last name, and GPA with their corresponding values. So I have this file or this call indented so you could see what it would look like in the actual XML format, because when you print out an XML document, you typically see it in this type of format where every subnode is indented one from its parent. So this is pretty much what the layout is going to be. And because of the ability for us to pass in multiple objects per constructor of each either XML or X document or X element, it allows us to build complex XML documents very easily, as this was done in basically in one statement. Then once we've built the document up, we return doc. Now we're going to use this document for all of our testing within the main function. Okay, so first we read it in, then I output the document itself, then I pause, then we're going to do our first query. Using standard LinQ syntax, we're going to create a var. It's going to be an IEnumerable of, in this case, I ordered enumerable of X elements, but instead of having to type that in, I'm just going to use var, which seems to be the standard these days for doing LinQ queries. We're going to call it honor roll. Now the honor roll is typically defined as somebody having a GPA of 3 or 3.5 or higher. We're just going to make the arbitrary decision of 3.5. So what we're going to do is declare the source of the data as the descendants of the XML document, where the descendants' names are student. if we were to look at the actual XML document again, you'll see it's going to pull back these 3 records because it takes a look at the document and finds all of the descendants with this name of student. Now, care has to be taken here in that if you have children with the exact same name as their parents, or possibly any other descendants with the exact same name, this will not discriminate against that. So anytime that happens, it'll pull back both records. So if you have a parent node with the name student, and then a grandchild node under that also called student, they will both be pulled back in this particular example. Next, we do our filtering criteria. What we're going to say is, for every element within the student X element that's called GPA, cast it to a float, and then test to make sure it's greater than or equal to 3.5. Now let's just read that in plain English. We're saying select from the document where all the descendants have a node called student, where there is an element within student called GPA that is greater than 3.5. Then we can, in addition to filtering, we can do a sort. So we're saying order by, and again we're converting the element called GPA into a float. And we're going to do it in descending order. So the person with the highest GPA will be first, and the lowest will be last. And then we'll select that student. Now, if we take a look at student here, student is going to be an X element. So when we loop through the query called honor roll, every student in this case is going to be an X element. Okay? So we are going to not see the individual data items. We're actually going to see XML subrecords. Let's go ahead and run up to that point. Okay, so the first part was run where we print out the entire document, and you can see that's the structure that we gave it. Okay, so if we were to look at this right now, we would see that Jane Smith and John Doe are the only 2 that have GPAs that would qualify for the honor roll. So unfortunately, Brad Jones was left out of the mix. So if we hit enter, you'll see that we do in fact have Jane Smith with the GPA of 4, and then John Doe with the GPA of 3.78. Remember, we applied a sort order to this, so even though John Doe came first in the source document, Jane Smith had a superior GPA, so she will be listed first. And notice that the X elements that came out start with the student node, and that is because that is what we selected. Remember, we said from student, this is the object we're selecting, and we're selecting all objects or all X elements that have the name student. So that would be the object that we're actually selecting. And then remember, we're saying with that student object, look at one of its child elements called GPA. And that's how we're doing the sorting and the filtering. Let's move down to this select projected types. Now this is going to pretty much do the exact same query. However, instead of selecting an X element for each student, we may want to select a different type. Now we could also, instead of doing a projected type, remember which is an anonymous type, we can actually use a concrete type. So if we had a class called student, and we could pass these items to its constructor as well, and then we could select those objects as well. But that's just a simple little change from this, where we're actually just selecting a new anonymous object. Let me make this smaller so we can actually see everything on one. Oh, I'm still running. So we see enough though. Okay, so what we're going to do is do the second honor roll query, and you're not going to see anything different for the first 4 lines except for the name of the query itself. Where it changes, instead of saying select student as we did in the first example, what we're doing is saying select new, and then we're going to create an anonymous type. Remember, with anonymous types, all you have to do is specify a name for each of the properties in the type, and then the value it is going to be. So we're saying create a new object where there's a property called last name and set it equal to the student's element called last name's value. And then create yet another property called first name and set it equal to the first name's value. I could have done GPA as well. You can do whatever you like. For instance, if I wanted to, I could create something called full name. So let me stop the execution so I can actually make some modifications here. So we have the ability to select new, and I'm going to actually reformat this to possibly make it a little easier to read. And then we can say GPA is equal to, okay, now GPA, in this case, because the anonymous type will infer the value, it's going to come back as whatever it is stored in the XML structure. Since all data in XML is a string, if we wanted to convert it to a float like we did up there, we could. But I'm just going to leave it as it is right now, just to demonstrate it. And then I could say something like full name, and then I'll have that equal to, and we could do several different things. We can say string.format, and then 0, 1, and then we can do last name's value, and then first name's value as such. So then if we run this, I will bring the window back into focus. Press enter. So that was the first query where we selected the honor roll based on the 3.5 GPA, and it returns X elements. Now we're going to do the one with projected types, and as you can see here, when it returns the values, see a last name is Smith, first name is Jane, GPA. I forgot to change the value. I have it set to GPA equals Jane. That's funny. Full name is Smith, Jane, and Doe, John. So we should probably fix this to return GPA. Yes, this is all unscripted. Okay, I'll move this back over to the right. There. So now you can see GPA is 4 and 3.78. I'll show you that last sample right now. And remember, with anonymous types, properties cannot be changed. So if you create this anonymous type, but you decide, oh, I want to change GPA, you can't do it once it's created. All of the properties are read-only. So keep that in mind. Okay, we do the final pause there between the two tests. Now we're going to use LinqToXml to create a new document. So what we're going to do is say create a new X document, and we're going to provide the declaration and comment like we did in the makeXMLDoc method. As you can see here, nothing looks really any different except for the name of the comment here. And then what we're going to do is we're going to pass in, when we say new X element students, like we did in makeXMLDoc, the difference is instead of actually passing it a concrete object like a new X element, we are going to pass it a query. So what we're saying is create a new document, and its root node is going to be students, and then we're going to select all of the student objects from the source document where the ID is less than 500,000. So as you can see here, we cast to an int before we do the test, because remember, everything's stored as a string. And then we're going to order by the last name, comma, first name, and then we select student. So this student, remember, is going to be an X element. So that is going to be the basis for the objects added underneath the student's parent node. So this is the root element, students, and it's going to have other objects called student because that's what we named it here in the original document. So that is going to be the root of the query will be each of these individual students as such, and those will be added to our new document here. Okay, and just to make it perfectly clear that this is a new document, I'm going to call it new students. Okay, and then we'll run this again, and then we'll jump to that part. Here it is. So here is our new document. As you can see here, students with IDs between 0 and 4999999 or 499999. And then the root node is new students. And you can see we selected those two X elements from the source document and just basically added them to our new students node in this new document. So knowing how to use LinQ and the X document model in LinqToXml is extremely useful for parsing documents and for actually creating new documents. Now, there is another thing you might be interested in looking at, and it is the OpenXML format used by Microsoft documents, such as Excel, Word, etc. Actually, the newest versions of Office, their XLSX file and DOCX type files are actually zip files. And if you were to look into those zip files, what you're going to see is a series of XML files. And they provide an object model for you if you wish to download it to actually parse these. They change the names or inherited from X document and X element, etc., and made them derived types that correspond to the different elements of those Office style documents. It's a very powerful LinqToXml tool, which if you need to edit or read XML document files from either Word, Excel, PowerPoint, etc., you can do that without having to buy an expensive third-party library or acquiring client computers where you're going to use this technology. They don't have to actually have Office installed, because normally you'd have to attach directly to the Office object models built into Office. This way it allows you to actually interrogate the documents directly. So you may want to take a look at that as well. It's a nice additional follow-on to this particular technology.